Hello, everyone. Sorry for missing out last week, but we're back with Thomas Tool Tuesday. I'm a little sick, so I apologize for the voice sounding a little weird today. But we're going to be talking about another tool that's right at your fingertips that's provided by MZZU Meteorology that you can use in both forecasting and research applications. That's the MZZU Radar. You can click on that, it's the last tab and towards the top of the page that you can click on. And you get a little description about the MZZU Weather Radar there. It's a research radar that allows students to use real-world data for their research applications. It also is the stopgap between the St. Louis and Kansas City radars, or LSX and EAX separately. So if you're looking at a mesocyclone, a rotating column of air, you have a radar that's over 100 miles away if you're looking at St. Louis or Kansas City. So you're quite high off the ground when you're that far away. The beam is straight, the Earth is curved, so you're getting higher and higher off the ground. With the MZZU radar, if you have a mesocyclone that's somewhat close to it, it's within its range, it will give you a significantly better picture, a significantly more low-level picture of what exactly is going on within the storm, and that can be critical for National Weather Service forecasters beyond research applications. So when it comes to this radar, we can also use this as an opportunity to say, where can you get the data? There are a few places. Radar Omega has it. GR Level 2 Analyst has it, and the free website where you can get it is right here on weather.missouri.edu. You just scroll down a bit, and you can see the real-time radar data there, completely free, no charges necessary. And I also thought this would be a nice opportunity to go over what these different radar products are. Some of you are very familiar with these in your upper-level meteorology courses. Some of you are probably looking into the screen saying, well, I've never heard of reflectivity or velocity or CC before. So let's go over those real quick and talk about what they do. Reflectivity is essentially the classic radar image. It is, what are we looking at? The higher the reflectivity, the heavier the rainfall generally. That's not absolute, but essentially, let's say you have a cloud with a bunch of droplets in it. The more droplets there are, the more reflective that part of the cloud's going to be. So a beam heads in, however much of that beam comes back, that tells the radar, okay, how much of my beam is getting reflected back to me. And that's what you see. So that's classic radar that shows you how heavy rain is, if there's hail, gives you a good idea of the structure of a storm as well. So we love using reflectivity. It is the first thing that people go to. Then we have velocity, and this is where the Doppler part of Doppler radar comes in. So we're looking at how fast air or hydrometeors are moving. So how fast are dust particles, are raindrops moving, are ice pellets moving. And this is really useful, but there's one caveat, and that is that it can only tell you the speed at which something is moving toward or away from the radar. It cannot give you any information on what's happening perpendicular to the beam. It can only tell you what's happening parallel to the beam. So that's why we look at reds and greens next to each other for couplets, because at the point where the beam is parallel, you'll notice there it is, the reds and the greens next to each other. That's how we know that things are bad. So it is useful in some sense, but it puts the Doppler and Doppler radar. How fast is something moving towards or away from the radar? Again, that's how those velocity couplets work. That's what velocity is. And finally, we have the cross-correlation ratio, better known as the correlation coefficient, that we'll go over today. There are some other products that we can go over as well at another time, but this is the third major one that people use somewhat frequently. This is the cross-correlation ratio, and this tells you, let's say that we have two rain droplets next to each other. The radar is going to scan them, and it's going to say how similar are these to one another. If they're very similar, then you're going to get a cross-correlation closer to 1. If they're not super similar, let's say one is in the shape and is a bit wider and is more elongated and the other is more spherical, your cross-correlation is going to be a little lower. Now for raindrops, for snow, stuff like that, even with the variance in there, you can get sometimes cross correlations of 0.9, 0.8, where this is also useful is in spotting debris from mesocyclones and tornadoes, where once you get cross correlations of 0.8, 0.7 and below, that's when you know you're getting debris from tornadoes. Some of the most extreme tornadoes can get cross correlations all the way down to 0.2s, where you'll have giant hunks of roofs next to raindrops, for example. So that's what I have for today with the MZZU radar. It is a critical tool in both weather research and operational forecasting and nowcasting for the National Weather Service. I hope you enjoyed this video, and we'll be back next week with the next Thomas Tool Tuesday.